Hey guys, welcome to section 6.5. We're finally starting to transform our sine functions. So far you should be comfortable with a periodic function and all the definitions that go along with it. And we're going to have to remember your basic 5 points in order to transform our functions. So a quick refresher. If you imagined a nail on a wheel that goes around, we are looking at the height of the wheel to the water level. Essentially is what's happening, and when you look at those heights, we can use our sine ratio to calculate the height, and we should be able to produce this curve. Now, you don't need to memorize all of the points, just the main 5. So if we look at when it's right at the water level, when it's rotated up to 90 degrees, 180, down to 270 degrees, and back to 360 or 0, these would be the main angles of rotation that you have to know, and then the matching height. So at 0 degrees, we have a height of 0, at 90 degrees, a height of 1, 180, a height of 0, and 270, a height of -1 because it's under the water level, and 360 is 0. So that gives you these 1, 2, 3, 4, and 5 points. Okay, there's one more thing that you need to remember, and this goes back to the curve sketching that we did when we were together in February and March. Most of our functions, and we were dealing with quadratics at the time, but we could take any of our functions and we could transform them by looking at certain parts of our equation. So regardless of whatever your function was, we had a value added to the end and one that was inside the function. If you remember your quadratics being in vertex form, we could get this information pretty easily. So the C value would take your graph and move it up and down, and the D value would move it left and right. Now, the only thing you had to remember with the D value is because there is a minus sign inside your bracket. If we had a positive number, it would read X minus the number. If we had a negative number like -3, X minus -3, right? X minus -3, that's the same as adding 3, right? Remember, we don't like having double signs beside each other. So you do have to remember your integer rules there. So just one of the short forms that we took that I tried to help you with was whatever the sign is inside the brackets, it's going to be backwards. So inside the brackets will be backwards. So if it says minus a number, it means you're going to the right. If it says plus a number, you're going to the left, okay? All right, so let's focus on C, and then we're going to focus on D after. So all of these transformations can apply with your trig functions as well as your quadratics. So let's come down here. If I have a basic sine function, if I have a number added to it, that is a vertical shift up or down. So let's take a look at this one here. I'm going to plot my main 5 points, and then I'm going to use this transformation to graph the rest, or to curve sketch. So because this number is being added, essentially what's going to happen is my graph is going to be shifted up 2 units, okay? It's a +2, so it's going to go up 2. So if you ever hear something about a vertical displacement, it just means up 2 units. Okay, all right, so let's graph our main 5 points. Now, I know these degrees are really small. They go up by 30s. So this is 0. I'm going to want the 90, okay, the 270, the 180. So we'll go through. So our first main point is 0, 0. I'm going to put a dot there. Then at 90, we had a +1. Now, I'm going to change these because it's really hard to see. I actually went up by different amounts, but I think we should. Oh, I can't do that actually because I forgot about my shift. There we go. So, sorry, so it's 0, 0. These go up by 2. So this is 2, this is 4, this is -2, and -4. Okay, so I have a point at 0, 0, and then I have a point at 90 and 1. That would be right there. I have a point at 180 and 0, a point at 270 and -1, and a point at 360 and 0. Okay, those are the points you had to memorize. You should know you're going to get a pretty curve. Don't draw me zigzags, they're pretty curves. So this is essentially what our basic sine function would look like. But this function has been shifted up 2 units. So I'm going to take each one of these points and bring it upwards 2 units. So if this was at 0, now it's going to be at 2. And let me pick a different color. There it is, 2. And if this one was at 1, 1 plus 2 is 3. So this one's going to be at 3. This one was at 0. It's going to go back to 2. This was at -1. -1 plus 2 is +1. And this was at 0. It's going to be back at 2. Okay. Now, again, you can kind of see your pattern going. I actually like taking my equation of the axis and I draw it out. I like seeing it. It helps me see things clearer. So if my x-axis was here, this was my original equation of the axis. It's been shifted up to, I'm actually going to redraw my equation of the axis right there. And you can see that my sine function kind of, if you imagined that as your new x-axis, would be your 0, 1, 0, -1, 0. Okay? So I'm going to do my best to draw it. I'm going to start here. It's a little easier for me. And if you connect your dots, remember, do your best. It's not going to be perfect, but you should get some kind of sine function like that. Okay? And now the rest of our, the rest of our answers here can be easily seen from your graph. So the amplitude, remember, is the height from your equation of the axis. It has not been stretched or compressed, so our amplitude is still 1. The period is the length of your graph. We are going from 0 degrees to 360 because it has not been horizontally stretched or compressed, so we're still at 360 degrees. Our maximum value is over here, which is around 3. And our minimum is down here, which would be at 1. Okay, so the hardest part is just realizing that when you have a number added to your function, it will give you a vertical shift up or down. Okay, now what happens if our number is being added or subtracted to your angle? So let's come back up here to our review. There it is. It's like having a number added or subtracted inside your brackets or inside your function. So if you see the brackets and the numbers on the inside, it's going to be a left or right shift instead of an up or down one. So these are called phase shifts. A negative phase shift means it's going to the left, but that means inside your brackets it'll have a plus sign because there's a minus in your equation. And then a positive phase shift will move to the right. Again, in your brackets, then it would say x minus a number because there's a minus in your equation. So anything that looks like this with a set of brackets will be going left or right, and it'll be going left or right by d units, okay? So if it's -2, it's going right 2. If it's plus 300, it's going left 300. Okay, so let's look at an example. Oh, this should say sine, I'm sorry. There we go. So we're going to draw sine of theta plus 240, and we're going to look at the phase shift, the amplitude, period, maximum. So again, please start off with your basic function. So start at 0, 0. Remember, it's 0. At 90, it's 1. At 180, it's 0. At 270, it's -1. And at 360, which I think is right there, it's back at 0. Okay, so we get a very pretty graph. I'm going to put some other points in just so you can see it. There we go. Okay, so that's what your graph looks like. Now, we are going to be shifting this thing 240 degrees. Because there is a plus sign, it means this is going to go left 240 degrees, okay? And remember, it goes left because really it should be theta minus a number. So if we put a -240, when you subtract a negative, it would be a positive sign. That's why we see the plus. So yes, I understand it's a plus. It is moving to the left, okay? So you are going to take every one of these dots and you are going to move them left 240 degrees. Just take your 5 main points and go left 240. So 0 minus 240, this dot is going to move here. This one that was at 90, 90 minus 240 should be 150. Okay. This one here at 180, 180 minus 240, and 2, 4, 6 should be at minus 60. I'm double checking my math. And 360 minus 240 should be at 120, which is there. Oh, I forgot this one down here. 270 minus 240 is at 30. There we go. So those are my 5 main points, 1, 2, 3, 4, and 5. I have shifted it left 240 degrees, and you've got your graph. I'm just putting in some other dots so you can see it a little bit clearer. I'll do my best to draw, so connect your dots now and make a really pretty curve. There you go. All right, and now we can use our curve to identify anything else that might be happening or to answer these questions at the side. So remember, amplitude is the height from our equation of the axis all the way up to the highest point. We haven't stretched or compressed it. Our amplitude is still 1. Oops, there, our amplitude. The period is the distance from here to here, the start to the end of a single cycle. And we have gone from 240 degrees up to 120 degrees. It has not changed at all. We are still at a period of 360 degrees. Our maximum is at 1 and our minimum is at -1. Okay, our highest point and our lowest point. Our highest point and our lowest point. Okay. So far, so good. Those are the left and right and up and down transformations. The next slide I've provided is straight from your textbook. It's just summarizing what happens and how to move it up or down and left and right. And I want to do just one more example with you where we combine a few of them. This one is perfectly fine. We're looking at a sine function. We're going to graph it, the basic one. We're going to look at the transformations, we're going to graph the new function, and then we're going to look at domain and range, equation of the axis, amplitude, and period. I actually like doing these before I graph it, but it really doesn't matter which way you look at it. So when I see this, I notice that this means it's going to go up 2. It is a positive 2, so my equation of the axis, instead of being down here, is actually going to be up here. This 45, it is a plus 45, which means it's going to go left 45 degrees. Okay, and then we can work on domain and range in the equation afterwards. So the first thing we need to do is put in all of our main points. Let's start off. We can actually go up by 30, so 30, 60, 90. Oh, let me put this in black. So this is going to be 90. Then 120, 150, 180, okay? And all I'm doing is I'm just going up by 30s. Those are usually really easy to work with. 2, 3, this is 270. And then if I mark these down, it's really simple to put our points down. 1, 2, 3, and this one would be 360 degrees. Although it doesn't look like 360. There it is. Okay, let's get our graph going. So basic sine function, 0, 1, 0, -1, 0. Okay. Sorry, I've gone up by 0.5s. There we go. And if you connect your dots, there we go. There's your sine curve. Okay. Let's now graph our new functions. So we've graphed our basic, I've talked about the transformations, and now we're going to graph our new one. So let's put this one in blue. Each point is going to go up 2 and left 45 degrees. Now, 45 degrees would be 1.5 squares. Okay, so I'm going to go up 2 and left 1.5 squares. This point isn't really going to fit on my graph. I'm just going to kind of estimate that it's there. This one here, I'm going to go, oh shoot, I'm going to go up 2, 1, 2, and left 1.5 squares. There we go. And I just realized I went up only 1 unit here. So up 2 units and left 1.5 squares. Okay. This one here, I'm going to go up 2 units, 1, 2, and left 45 degrees. I'm going to take this main point, I'm going to go up 2 units and left 45 degrees. Remember, 45 degrees is 1.5 squares based on the way that I have drawn them. And then this one here, I'm going to go up 1, 2 units and left 45 degrees, again, which is 1.5 squares. Okay, connect your dots Do your best. Do not draw me diagonals. These are curves. Okay. And I'm just trying, oh, this is I want to put my equation of the axis in here. I hope this works. There we go. Okay, so there's our equation of the axis there. Okay, so now coming up, we've got it graphed, we've shifted it up to and left 45 degrees, and that's exactly what it looks like. Our domain would be all of the real numbers. We talked about this the other day. Our range going up and down, it cannot be lower. Now we're looking at the blue graph, right? So it can't be lower than 1 or higher than 3. So the range are all of the real numbers, such that y must be greater than or equal to 1, but less than or equal to 3. And then close it off in your brace brackets or your curly brackets. The equation of the axis was the blue line going across that we drew in. You can find it by taking 3, adding it to 1, and dividing by 2. That should give us a value of 2. And if you look, we drew our line at 2. It's right in between, okay? The amplitude is the distance from the equation of the axis to the highest point. So we're going from 2 to 3. That has an amplitude of 1. And the period is the length of a cycle. We didn't compress it or stretch it at all, so we still have a period of 360 degrees. Okay, so there you have it. You can graph left and right, up and down, and you should be quite good with your curve sketching. Okay, guys, have a great one. Tomorrow we're going to look at your compressions and your stretches for any kind of vertical value, and then you're done. Have a great day.